Right, in this video we're going to look at the nth term of a quadratic sequence. What you should note first is that there are different types of sequences. I have done a video on nth term of arithmetic sequence. I would suggest you look at that first because arithmetic sequences are a little bit easier. Actually, they're a lot easier than quadratic sequences. And at the moment, quadratic sequence is on the higher GCSE specification only, and that is at the moment. Okay, so a typical question would look like this: find the first 5 terms of a quadratic sequence. Sorry, these are them. Find an expression in terms of n for the nth term of this sequence. So first of all, if it's the nth term I'm looking for, my answer is going to look something like this: some number a multiplied by n squared. And if you remember from arithmetic sequences, n is the position in the sequence, plus some number, let's call it b, multiplied by n, plus or minus some other number, we'll call it c. So what you've got here is you have got a quadratic expression, the same as when you expand double brackets in algebra, you end up with a quadratic expression. You might have factorized quadratics already, quadratic formula, etc., etc. This takes the exact same form. What makes this a quadratic is this to the power of 2 here. If you didn't have the power of 2, it wouldn't be a quadratic sequence. That's the most important bit of it. There might be times where we don't have a b value, so it'll be plus nothing there. Other times we might have a number on its own at all. So again, it'd be plus 0 or just nothing there at all. But that is the general form for a quadratic sequence. So that's the first thing to note. Our answer will look something like this. We need to find a, b, and c. With any sequence, the first thing you note is what is it changing by each time. So in my sequence here, we're going from minus 10 to plus 2. So we've added 12 there. On this one, we're going from 2 to 18. So actually we've added 16 here. What you might note straight away is these aren't the same. Going back to arithmetic sequences, the first difference was always the same. But let's keep going with this and see what's happening. So this is plus 20. And next we've got plus 24. So we're going up in 12, 16, 20, 24. What you should see here is that actually that difference, it's changed by the same amount each time. We're adding 4 every time. And that's what makes it a quadratic. So that's the second difference. So that's our first step. Second step, and this is probably the hardest bit because you need to remember these expressions. We're going to take this first number, minus 10. What I'm going to do is I'm going to form an algebraic equation with it. I'm going to say a plus b plus c is equal to minus 10. I'm not going to do anything with that at the moment because you excuse me, as you notice we've got 3 variables which doesn't make it solvable at the moment. If I can find the value of 2 of these variables, then I can find that third one. So what I'm going to do is I'm going to go to this second number here, so that first difference, and it's plus 12. What I'm going to do with this is I'm going to say that 3a plus b is equal to 12. Again, I can't do much with this because again I've still got 2 variables here. I need to have 1 in order to solve. So finally, what I'm going to do is go to this plus 4. I'm going to say that 2a is equal to 4. And we can see that that is solvable. So what I've done here, I'm not going to rush ahead. If you lay it out carefully like so, you're taking that first number in each line every time. That's going to form your equation. You will always use a plus b plus c, and that will always be equal to the first term in the sequence. You will always use 3a plus b, and that will always be equal to this first difference here. And finally, you will always use 2a, and that will always be equal to the second difference down here. So we're using the first number in each row every time. Now I'm going to start with the 2a because that's the one that I can solve. So I'm going to solve from right to left. So first of all, 2a is equal to 4. If I divide both sides by 2, then a is equal to 2. So that's my first solution. And later on, that's going to go into this equation up here. So working across, because we know what a is, now I've got 3 times 2 plus something is equal to 12. So here we've got 6 plus something is equal to 12. Take that 6 away from both sides. We know that b is equal to 6. So again, that will go into my expression up here later on and be part of my answer. Finally, we know that a is 2. We found that earlier on. We know now that b is 6 plus something is equal to minus 10. So 8 plus something is equal to minus 10. Oh, jumping ahead there a bit. Take 8 away from both sides. So minus 10 minus 8 is minus 18. And that is your solution for C. Lastly, because we need an answer to this, we know from earlier that our answer needs to take this form. A times n squared. A we're saying is 2. Plus b, which is 6, n, and then plus our c value. Our c value is minus 18, so minus 18 goes in here, and that is your answer. So just to reiterate, 3 key things to take from it. A plus b plus c you need to remember, 3a plus b you need to remember, and 2a you need to remember as well. Here's another example. What I would advise is pause the video, see how much of it you can remember, think about those first difference, second difference, and see if you can remember those expressions as well to create those equations. Okay, so pause the video now. Right, let's see how you did on these. So first of all, I know that my answer, because it's the nth term, it's going to be in the form an squared plus bn plus c. I've got 22, 29, 44, 67 and 98, some big numbers here. So first difference is 7, and it's a plus. Make sure you're putting in whether it's positive or negative. Second difference, I believe, is 15. Next difference, I'm presuming it's going up in 8s, 23, yeah, that's correct, plus 23. So this one should be plus 31. Let me just check. Yeah, you're adding 31 now. So as I stated already, that difference, we're adding 8 on each time, and that's our second difference. So you've picked up a mark already if you've got those down. So next step is this first number here in the sequence, first term in the sequence, a plus b plus c equals 22. The first difference is plus 7, so that would be 3a plus b is equal to 7. And then lastly, that second difference, plus 8, we've got 2a is equal to 8. If you wish, pause the video again and see if you can finish this off, if you didn't get this far so far. Right, so we're going to start from the right and get this a value first. It's 2 times a, so we need to divide by 2 on both sides. So a is equal to 4. Bring that over here. So we're now looking at 3 times 4 plus something is equal to 7. So 12 plus something is 7. You can probably spot what it is already. We need to take 12 away from both sides. So b is equal to minus 5. Make sure you got that negative in there. And lastly, we know a is 4 plus b is minus 5. Make sure you bring that minus. Plus something is equal to 22. What I should say here is always make sure you're working down the page as well, okay? That makes it a lot easier for you to see what you're doing, and also for anyone who's marking you as well. 4 minus 5 is minus 1, plus something is 22. So let's get rid of this minus 1. Let's add 1 to both sides. So c is equal to 23. And finally, so we know that it's an squared, which is 4n squared, plus bn. B is minus 5, so that needs to be a minus 5n. And lastly, plus c, it's plus 23. That is your answer. Hopefully you got that right. If not, again, probably take note of a plus b plus c, 3a plus b, and 2a. They're the expressions you need to remember. The more of these you do, the easier it'll be as well for you to remember them, okay? And you're always using those 3 values down along there. Right, we got one more to go. So, see how you can do on this. Remember your expressions. Follow that same pattern that I do, working down the page, and then from right to left when you're solving those equations. Pause the video now. Okay, so it's the n term again. So my answer needs to be in the form an squared plus bn plus c. Let's find those differences. So it looks to me that first one goes up by 9. So plus 9 here. And then we're going from 37 to 50, which is plus 13. Make sure you take your time on these. I am rushing it a little bit, but if you make a silly mistake here, it's going to throw everything off later on. We don't want to make a mistake on the adding bit. So there's plus 17 there. And here we've got plus 21, I believe. And what you should find here is that this second difference, it needs to be consistent. So I'm plussing 4, plussing 4, plussing 4. If you find that it's not the same thing every time, you need to go back here. You've made a mistake somewhere here, okay? That always needs to be consistent. So that's our first bit. Bringing it along, we're going to go for that first term we know needs to be a plus b plus c. The first difference is always 3a plus b. And finally, the second difference, that consistent difference, or constant difference I should say, is always equal to 2a. And again, starting from right to left, working our way across, divide by 2 here because it's multiplying by 2. So a is equal to 2. We now know that it needs to be 3 times 2 plus something is equal to 9. So it's 6 plus something equals 9. We know what that is, but do make sure you're showing your workings in case you make a silly mistake. So we're minusing 6 technically from both sides. So b is equal to 3. And finally, a is 2, b is 3, c we don't know, but we do know that those 3 numbers need to add to 28. So 5 plus something is 28. Again, pretty obvious the answer there is 23, but show what you're doing each time. Just like when we're solving equations as well, we want both sides to balance. So c is equal to 23. And finally, do make sure you put it into, because you're going to drop a silly mark at the end if you don't put it into this form. So a is 2, n squared plus bn, so that'd be plus 3n plus c, which is 23. And that's our solution. We can check if we're right, so I chose not to show you this yet. If we look up here, the first question I said that n is the position in the sequence, and that goes back to as well what we did with arithmetic sequences using dino, etc., etc., is the position in the sequence. So the first position in the sequence, the first term, is here, n equals 1, and we should get 28. So if I go down here, and instead of writing down n every time here, if I write down 1, what I should get is 28 if I've done this correct. So 2 times 1 squared. Let's be careful with that squared bit, and remember that we need to use business. So doing the square bit first, 1 squared is 1, 2 times 1 is 2, plus 3 times 1 is 3, plus 23. Add these three numbers together, we end up with 25 plus 23, which is 28, which is correct. That is the first term in the sequence, n equals 1, so this must be correct. We could do it for the same up here, n equals 2. So if you wanted to see what you get on this one, substitute 2 in there, and you should get 37 as your solution. Hopefully that was a help to you. Remember, practice these as much as you can, and you will remember these three expressions that create your three equations very easily then.